Okay, so here's a problem we could try to solve graphically. Um, that means that we're going to draw a graph of it and try to figure out what it is. So I would suggest that you take your calculator at this time and graph this function, and then we will come back and look at it, okay? So take your calculator and graph it, and then you can pause the video first, and then you can come back and find out what it is. Here's my function that I've got typed in. Be sure you've got both numerator and denominator in parentheses. Here's our standard graph of looking at this curve. And we're wanting to figure out what the limit is as x approaches 1. Now, I have the ability to pull my graph right over here, so I'm going to pull it over and blow it up a little bit, and let's see if we can determine what's happening. We're worried about what's happening as x approaches the number 1. So let's see, here's x equals 1 right there. And if we look to the right of it, it looks like it's coming down here somewhere in this area right here, doesn't it? That's very hard to figure out what that number is. Looks like it might be the number 2, it might be the number 1. It's just very hard to determine by looking at the graph here because it's hard to read. So how could we get a better solution for that? Well, let's look at this chart that we've created down here. Can we figure out what the function value is at each one of these? I think we can. If we go back to our calculator here, if we go and were to look at a table set, so if we go second, if we go to our calculator and we choose second table set, let's just put these numbers in one at a time and try to figure out what they are. If we put in 0.9, what we're going up by doesn't really matter. And second table, let's do this. I'm going to change my rules here. I'm going to say let's go down to let's change our delta table to 0.01. And now let's look at our table set and see what we get. Okay? So at 0.9, it looks like the function is 2.71. So that you can write that into your chart right here, 2.71. And what if we scroll down? Can we scroll down far enough to see what 0.99 is? Let's see. If we scroll down, 7, 8, 9. 0.99 is 0.297. So let's go back over here and write that in, 2.97. And you can continue that process for each of these numbers. So let's go ahead and try to fill in this entire chart. 0.99, getting up to 0.999 may be a little challenging here. So what could we do here? Let's notice what happens when we get to the number 1. We get an error. Well, that's in our chart, but we don't know what that is. So let's just type in ERR here. All right, or write ERR in. Now let's take our calculator and fill in these other numbers. It's kind of a tedious process to begin with, but let's just try it. So we're going to go here and press second. Going to go to table. And where do I need to start at? I want to start at 0.999. I didn't get a decimal in there. Alright, and second table. And at 0.999 it's 2.997. So I want you to just take a moment now and look at what is happening with our function values. X is getting closer and closer to 1. And it started off at 0.9, it's 2.71. At 0.99, it's 2.97. At 0.999, it's 2.97. And then at 1, it's errored out. Well, just looking at these numbers, what would you say it's getting close to? It went to 2.97, then 2.97 again. If we actually move over into the table there, we see it was 2.997001. So it's a little bit higher there. So it looks like the function just keeps going up. And if you look in your chart up here, you'll notice that at 1.009, it's 3.02. Well, what if we go on down our list? Well, we don't have anything. We don't have our numbers there. So let's get these numbers on the right side and see what happens with them. So second table. And now let's start at 1.001 and look at a table set. And at 1.001, this number right here, it's at 3.003. So, now let's take a moment and look at 0.999, it was at 2.97. When we crossed over to the other side, it's at 3.003. So I wonder what this number is getting close to here. Well, what's kind of between 2.997 and 3.003? It looks like it's approaching the number 3, I would say. And if you go to your calculator and find out what 1.001 is and 1.1, you're going to find that they're very similar. They're going to be larger than this, probably 3.003, and that's probably going to be 3.29 or 3.3, something like that. But it looks like whether we're from the right of the function moving down, that's these numbers here, we're approaching the number 3, or if we're to the left of the function, right here, moving up, we're approaching the number 3. So we can conclude from that that the limit is 3. This is an example, by using this chart down here, of solving this problem numerically by simply plugging in numbers around what we're looking for. Notice what happens when we plug in the number 1, we get an error. So if we had gotten a number out there, we could just know that the limit's that, more than likely. But since we didn't get a number, we have to look on both sides. So anytime you're evaluating a problem numerically, you look at values close to what you're looking for, close to 1, but it has to be on the left side of it, 0.9, 0.99, 0.999, and on the right side of it, 0.1, 0.01, 1.001. So you're just getting closer and closer each time. So this is an example of numerically. We've done graphically, we've done numerically, and it's a good way to check one from the other. Both answers should agree that you can find it that way.